All right, you guys, what's up? Welcome to lesson 3.8. This lesson, I'm going to be going over when to use each data structure. So more specifically, it's going to cover why choosing the right data structure matters, an overview of the Python data structures again, kind of as a recap, when to use lists, when you should use tuples, when you should use dictionaries, when to use sets, some examples and use cases, and then finally, it's going to end off with some more practice problems. So first, why choosing the right data structure matters. So choosing the right data structure improves performance, faster operations for tasks like searching, adding, or deleting data, which is really crucial when you're working on larger projects or just any project in general, right? This is what companies are really looking to optimize. This is what a lot of programming is, just optimizing these things, especially within algorithms. And picking the right data structure can speed this up a lot. So next, it also simplifies code. If you use the right data structures, it will make code easier to read and maintain. It also prevents errors. Using the wrong data structure can lead to inefficiencies or incorrect results. So you could actually mess up a lot more. So using the right data structure will just basically work as guardrails or the bumpers when you're bowling. So here's an overview again. So we have lists, which are ordered, mutable, allows duplicates. Some common use cases for lists include storing sequences of items and dynamic arrays, a tuple, which is the same as a list but immutable, it cannot be changed. Common use cases kind of fall under the category of fixed collections of related items. A dictionary has key value pairs, they're changeable, but each key must be unique. Some common use cases are fast lookups and structured data. A set is an unordered, mutable, only unique items. Some common use cases in Python are removing duplicates and mathematical operations. A string, a mutable sequence of characters, and common use cases are basically anytime you want to use text or language. So when to use lists? Use lists when the order of your data matters, when you need to maintain a sequence of it. An example is tracking a series of user actions. Every time the user does something, you can add that to a list, and then you'll have a chronological order. The first element, the first thing they do, the second element, the second thing they do, etc. Also use lists when you need to add or remove elements frequently without having to worry about it. So an example is a to-do list. You can just add another task to the end, and then you can remove a task really simply. When duplicates are allowed, because for some of these examples, dictionaries would work really good too, for dynamic size specifically, because you can store multiple things. But if you need to have multiple of the same item, like in a to-do list, you might have the same item in there twice, then a list is better than a dictionary potentially, depending on how you represent it. Because for a dictionary, you can't have the same key twice. You should avoid lists when you need fast lookups by key. Just use a dictionary because it's a lot quicker than indexing through an entire list. Or if you want unique elements, use a set. So here's when you can use tuples, or when you should use tuples. When data shouldn't change, you want the data to be immutable. Example, storing coordinates or RGB values that you don't want to ever change. When performance is important, tuples are faster than lists for read-only data. So actually accessing and reading the values in a tuple is going to be quicker than when you're reading them in a list. So you could also use tuples, or you should use tuples when you need hashable data. Example, like when they can be used as keys in dictionaries because they don't change ever. Mapping coordinates to a location name, mapping certain things to other things in a dictionary. Avoid tuples when you need to modify the data later. That's basically the only time. Tuples aren't used a ton because of this, because a lot of the times for data structures you do need to modify the data, but they're kind of underused by a lot of people. Now, for dictionaries, use them when you need a key value pair, when you need to map keys to values. Example, a phone book with names as keys and phone numbers as values. Really great use for a dictionary. When you need fast lookups, you use a dictionary because they provide O1 average time complexity, which when I get into data structures and algorithms in other courses, I'll kind of break this down better. but this is really good. This is what you want to be aiming for your code. It's usually not achievable, but dictionaries allow you to kind of do this. So next, structured data, storing data with multiple attributes. For example, a product catalog with names, prices, and stock levels. Great use for a dictionary. You should avoid dictionaries when the data set doesn't have a clear key value relationship. For that, you should just use a set or a list. Or when keys can be unpredictable or may repeat, you should just use a set or a list again. When to use sets? Sets are really underused. You will rarely see them, but it's still good to think about them and to use them more because they're pretty powerful and they can be a great solution for a lot of problems. So use a set when uniqueness matters. You need a collection of unique elements. Like if you're just storing email addresses, use a set. If you need fast membership testing to check if an item exists faster checking if an item exists is faster with sets than lists. So example, checking what usernames potentially have already been taken. Checking if an email is already in your newsletter. Things like that could be better for a set. Sets are great for whenever you're doing mathematical operations. So if you want to find the common elements in two different students in two classes, for example, you could use sets for that. Convert a list to a set or part of a dictionary to a set or whatever you might need to do. You should avoid sets when you need to maintain the order of elements or you require duplicates or you need to quickly find a specific item in it. You shouldn't use a set then either. Here's some examples and use cases. Scenario 1 for a student management system. You could use a list to store the names of all students, a dictionary to store each student's grades, and a set to store a unique list of clubs students have joined. So for an example on this could be here. So say you have like a school and this project is for an entire school, right? You have students equals name 1, name 2, name 3. Then you have dictionary, which would be grades equals, and then each of these would be associated with another list of grades. I'm just going to copy this over for all of them for simplicity's sake. Then you could have a set of clubs. So to do this, you could again use a dictionary linked to, hold on, this should be a dictionary actually. And eventually I'm going to have a course as well on like databases, and you'll start to understand how you can structure them better when representing data. But like in this example, this for a database, this would be the primary key and would have a one-to-one relationship with students and grades, etc. But there's a better way to represent this because if you're using tables and different databases, it'll make this a lot easier. But for example, for clubs, you can have name 1 is a part of club 1, 10, and 5, for example. Then they can't be part of two clubs. These are their grades in different classes. These are their student names, etc. You see, you can represent different parts of the same program with different data structures, just depending on how you want to utilize the data and what you're trying to accomplish. Here's another situation. For an e-commerce website, you can use a list to store product reviews, a tuple to store fixed products, a dictionary to store products with their attributes, and then a set to track unique customers who visited the site. So here, I'll try to write this out again. So this is for an e-commerce website. Product reviews equals. I love this product because dot dot dot. Or you could even separate this out further into like 1-star reviews, 2-star reviews, etc. But for simplicity, I'll do product reviews here. This could also be represented as a dictionary where you have kind of a list of reviews associated with each kind of star reviews, or however you want to go about it. I hate this product because. Okay, and then tuple to store fixed products. So products equals, and I'm actually going to change this to be a list of tuples. So actually I'm going to change it to be a dictionary. Dictionaries are really powerful, as you can see, and you could use dictionaries for a lot of things because you can assign values to each of the things that you are storing. So say you have like I'm gonna make a first one as key, again like I did in one of the past problems. So key of product ID category, and then here we have product 1, which will be associated with 1 category of health. Product 2, and fitness, or something like that. That should give you an idea, because now this will never be able to be changed. You can change what's associated with this if you want to just pass in a new tuple to that value, but you can't actually change the tuple in itself. So now a dictionary to store products with their attributes, which is kind of what we're doing here as well, but you can have things be variable because stock can change, price can change, etc. So you could actually even do that here. You can have a list here. And let me do that here as well. With a dictionary, or with another list here, which will be price, stock, just for all the labels. Or you could do it like this. Price, which is associated with the item's price, and stock, which is associated with how much we have. So then after that, we have a dictionary with price of 1,200. Oops. And then stock of 5, because I'm unoriginal. And then here we have price of 100, stock of 1. And then we can use a set to track unique visitors, customers who visited the site. Visits equals. And to do this, you really have to think of how you would represent these unique customers. For example, you could do emails. You could have people pass in their email kind of in terms of whenever they're accessing the site, collect their email, so then you can add it to a newsletter or just to track the unique visits. At gmail.com. Sam at yahoo.com. Fry at hotmail.com. And that would be a, hold on, where did I go wrong? Product 2. Oops. This is why it's important to run your code frequently for little syntax errors like that. But this would be a good way to represent an e-commerce website for a lot of its data. And then you could just display this a real simple way. Obviously, there's other things in Python and other programming things you would use for this for like a large scale project like databases and classes and object oriented features. But this is a very simple way if you want to just build out like a basic e-commerce website. This will scale to a certain amount. And then you could use this to easily look up like, okay, how am I storing the data here? What is this? How am I storing the data here? Or what reviews do I have? What's the price of product 1? You would just go products, product 1. And then it would be the first item in product 1, price. And that's how you would get the price. Or you could even, a better way to do this might be to just include this in the dictionary. So then you have, like this would be associated with like a metadata label. And then all of it's in the dictionary. Like that might be a better way to represent it. I don't know. You kind of, when you're designing it, you'll have to go through questions like this and just consider it. But it's good to know like things that you can do so you know how to do it in the future, if that makes sense. So now I'm going to get into some practice problems where you guys are going to go through similar things on your own. Do these to solidify your knowledge. Show them off to the community after. If you have any questions, post about in the community or just send me a DM. First, pause the video right here. Try to do it on your own. Get creative. Try to expand on it. Then come back and see me go through them. So first, I'm going to go through them now. Choose the appropriate data structure for the following tasks. Storing a sequence of daily temperatures. For that, I'm going to use a list because I can change it and I can keep adding stuff and it's a sequence of things. So daily temp equals 100, 200, 10, 40. Just keep adding to that. You can see, then you can plot over the day what the average was. You can plot the line graph on it very easily. Great way to store that. Store unique IDs of registered users. So for this, I probably want to use a set because they're all unique. But I also kind of feel like it's not that good because using a set here of, if you just have a set like this, then unique ID 1, 2, 3, 4. Usually unique IDs are going to be some incremental amount where you're incrementing based on like the previous one. So you would just add one more than the length to this. That's kind of repetitive when you're thinking about it, because if you just have users here and then a list of users that you can just keep expanding on, you could what you could do is you could just query where they are in here, but they do all have to be unique, so you have to make sure that it's not in there when you're adding it to it. So I'm actually just going to use a list again, or actually I could also use a dictionary where I just iterate each time, because that all these keys have to be unique. And then here I can do a tuple, I suppose, of like an ID. That's how I'm going to represent it. There's not really any wrong answers to this. These questions are just kind of to get you thinking about how you could approach these differently. But that's how I'm going to represent these, I guess. Or I don't even need a tuple here because it's just one value. So I'm just going to move those and do it like that. So then there's just a ID associated with each person. And then I guess you could also have a set containing each of those, just in case like you change someone's ID to make sure that it's not already in here, just for security. That could be good. But now mapping employee IDs to their email address. Employee emails. Dictionary obviously for that one. So ID of like 0 map to something at gmail.com. ID of 1 max at gmail.com, etc. And then if you want to get someone's email address, you just say you have a user here, and to get their ID you have 0 and 1. Say Max's email is something at gmail.com. What you would do is, in order to find Max's employee emails, you could just employee emails, and then inside of here do users Max, because you querying this will return whatever my ID is, and then that will pass into here, which will return whatever the associated value is. Here, let me do Fry now. Okay, exercise 2. Write a program to create a dictionary with product names as keys and prices as values. Use a set to store unique customer IDs. Use a list to maintain the order of purchases for a single customer. Okay, so products equals, I'm going to make a key at the top here. I don't know why I'm really filling the key. Price. Actually, no, I'm not going to do that. That doesn't make that much sense here. I could probably find a better way to do it, but product names. So you have like product. Here, let me change this actually to product prices, because then it just makes more sense in my head. Microphone 100. Mouse, but spell it right. 50. Keyboard 25. Desk 1000. Okay, so what's the next thing? Use a set to store unique customer IDs. Use a list to maintain. Here, I could just pass things in here. While you're doing these on your own, it might be good too to like add some control flow to it, to have like get user input, try to add it to them, try to change things, have it print out things, etc. So customer IDs, use a list to maintain the order of purchases for a single customer. Equals this, and then microphone they get first, then they get a desk, then they get a keyboard, just something like this, you know. And this, a lot of these, like this specifically, will be a lot better with using classes in the future to store the data and the sequence of everything. But for now, this is great. Thank you guys for watching. Hopefully you guys learned some stuff. Let me know if there's any questions again. See you guys in the next module.